Welcome to your Elements and Atoms video lecture. Today we're going to be talking about elements and atoms. First things first, we need to talk about matter. Matter is anything that takes up space and has a mass.
Matter.
So all matter is made of atoms, and atoms are the building blocks of matters. So if you picture a house, when you're building a house, you have bricks that build your house. So atoms are like the bricks of matter. So everything is made up of matter, and matter is anything that takes up space.
Atom.
Good job.
If we look inside our atoms, you may have learned 7th, 8th grade that an atom has 3 parts. We have our positive protons, which are over here in yellow with the pluses on them. We have our neutrons, which have no charge and are also over here in orange. And then we have our tiny electrons, which are circling outside in their electron shells and have a negative charge. These protons and neutrons right here, the yellow balls and orange balls, are found inside the nucleus. And the electrons, out here, these little white balls, are going to orbit outside the nucleus.
Elements.
Okay, so what are elements? Elements
Matter.
are the alphabetic language
Elements.
of molecules. In the classroom, we have the periodic table of elements listing all the elements on there. To make any molecule, you're going to have a combination of these elements. Elements are made of atoms, and while the atoms may have different weights and organizations, they're all built the same way. So we have all of these little tiny atoms that come together and will make an element. So if we have a whole bunch of atoms of hydrogen, they'll come together and they'll make hydrogen that we can see. Or nickel, if you've ever seen nickel, or gold. A whole bunch of tiny atoms come together to make an element.
Buongiorno, I am the pet rock. My name is Rocky. I am made of the matter.
So atoms always have as many electrons and protons. So in hydrogen right here, we have 1 proton here in the middle with our positive charge and 1 negative electron rotating outside. Helium is our second element on the periodic table, and it has 2 protons right here and 2 electrons rotating outside. Carbon, with an atomic number of 6, is going to have 6 yellow proton balls here and 6 electron balls rotating outside. They usually have almost the same number of neutrons as protons, but not always. So at carbon right here, you'll notice that it's 6, 6, 6. Helium, we've got 2 neutrons, 2 electrons, 2 protons. Hydrogen is different. It has no neutrons. And the further we get down in the periodic table, this neutron number is going to change drastically, and there'll be a gap between the number of protons and the number of neutrons. If we add a proton, it's going to make a new kind of atom. Adding a neutron makes it an isotope. So the more protons it has, if we add 1 proton to hydrogen, it becomes helium. But if we just add a neutron to make this 1, 1, 1, it's just going to be an isotope or a heavier version of that atom. It's still going to be hydrogen. It's just going to be heavier hydrogen because we've given it an additional atom. On our periodic table, we have all of these elements coming around here. And we're going to work with these 2 numbers, this O and the word right here. First off, this number 8 is going to be atomic number. It's the number of protons and the number of electrons in the atom. So that 8 right there for oxygen would mean that it would have 8 plus protons, yellow balls, and 8 white electron balls rotating around it. Oxygen, this big O, is the symbol or the abbreviation for the element. Oxygen is the name. And then our bottom down here is our atomic mass or weight. So it is the number of protons plus the number of neutrons. So if we go back here, our atomic mass down here is going to be protons plus neutrons. So the atomic mass for helium would be 4. Protons plus neutrons for carbon would be 12. This class, we're going to be working with 2 different models for the atoms. We're going to be using the Bohr model and a Lewis dot structure. For the Bohr model, it's going to show all of the particles of the atom. So here's our nucleus right inside, and then we've got our electrons floating outside. In the center is circles. Each circle represents a single neutron or proton. Protons will have this plus sign, so in this case they're the pinkish purple ones, and our neutrons will have no sign. And then if you don't want to put the signs in there, our neutrons will have an N and our protons will have a P. Our electrons are going to orbit around in circles. There may be more than one circle, and they're either going to have a negative symbol in them or an E for electron in them. Electrons have special rules. In this one, if we had more electrons than just the two, we would need to make more energy levels outside because only a certain number can fit in the energy levels. What you need to remember for these energy levels is that it is 2, I'll write these down for you, it's 2 in the first energy level, 8 in the next energy level, and then 18 in the final energy level that we're going to be dealing with. So only certain amounts of electrons can be in each shell or energy level. Right here is our nucleus, where all of our protons and neutrons will go. So we've got our protons and our neutrons inside this nucleus. Our first shell can hold 2 electrons, and they're not ever close together. You wouldn't have like 2 electrons right here. They are always pretty opposite. Our next one's going to have 8. And our final shell can hold 18 electrons. I'm not going to draw all 18 circles in that shell. So as we were talking about before, we can't just put all of the electrons into one energy level. And then this outermost shell where our electrons are is going to be called valence electrons. So our valence electrons follow a pattern on the periodic table, which you guys are going to discover next class. But valence electrons means the electrons in the outermost energy shell. Okay, so if we tried this right here, how to draw a lithium atom, first we're going to look at the periodic table. And as we're looking at this periodic table, we need to remember that up here is our atomic number, and our atomic number equals the number of protons and electrons, and our protons have what charge? Positive, and our electrons are going to have a negative charge. And then this 7 down here is going to equal the protons plus the neutrons, and that's our atomic mass. Even if we look at those Bohr models, these protons and neutrons are bigger than the electrons, so they hold most of the mass. So we need to determine the number of everything that we have. So we have protons, neutrons, and electrons. So our number of protons in this case is going to be 3 because it's our atomic number. We also know that that is our number of electrons because it is the atomic number. And we need to find our number of neutrons. So we know that our atomic mass down here is our protons plus our neutrons. So we can take our atomic mass, which is 7, which is protons plus neutrons, and we can subtract out the number of neutrons which we have, which we know up here is our atomic number. So our neutrons is going to be 7 minus 3, which is going to equal 4. So we know we have 4 neutrons. Our next step then is going to be to draw the nucleus of our atom. So inside the nucleus, what do we have? Protons and neutrons. So each proton will be represented by a ball. And our protons are positive, P for positive. And then we also need to draw 4 neutrons. And then our 4 neutrons need no charge because they're neutral. Outside around in energy levels, hopefully your circles look a little better than mine. We've got our electrons, and if we call from before, our energy levels are 2, 8, and then 18. So our first electron shell can hold 2. So we make this, and then we can put a minus in these. And then this shell is now full because it's held the max of 2. So we have one more electron out here that we need to put to make our electron total 3. So in this lithium right here, we would have one valence electron because in the outermost shell, this one little electron guy is hanging out. Here's just the computer animated model. All right, let's try it now with boron. So B here stands for boron. So our atomic number is 5. And the atomic number equals what two things? Our protons and our electrons. And then this atomic mass down here is our protons plus our neutrons. When we have atomic masses of like 10.86, it's okay to just round up and call this 11. So 11 protons plus neutrons minus 5 protons is going to give us 6 neutrons. And then we have 5 protons and 5 electrons. So to draw this, inside our nucleus, we have 6 neutrons. And neutrons have what charge? None. And then we have 5, what else goes in our nucleus here? Protons or electrons? Protons, so we put in 5 pluses. And then we need to draw our electrons on the outside. And how many electrons can we fit inside that first energy shell? Right, 2, because our pattern is 2, 8, 18. So boron will have 2 electrons here, minus, minus. We need 5 total, so we need 3 more. These will all be minus, minus, minus. So our boron is complete. We have our 6 neutrons, our 5 protons, our 5 electrons, and our valence electrons, or VE, again is our outermost, and we have 1, 2, 3. All right, Lewis dot structure. It's a little different from the Bohr model, which we just talked about. And it only is going to show the element symbol and the outermost.
Buongiorno. I am the pet rock. My name is Rocky. I am made of the matter.
Outermost electron shell, or our valence electrons. So for oxygen here, we had 2 in our inside, and then there's 6 valence electrons on the outside. So here you can see 1, 2, 3, 4, 5, 6 valence electrons on oxygen. Let's go back to this boron guy here. So for boron, we decided that we had 3 valence electrons. So to make our Lewis dot structure, we write the symbol in the middle, which is going to be V. And then we're going to make our valence electrons going clockwise. starting on the right. So we have 1, 2, 3 valence electrons for boron. If we were to do an element that was like neon, Ne, is going to have 8 valence electrons. So if we did neon, we'd start over here on our right. 1, 2, 3, 4, 5, 6, 7, 8. And when we do these Lewis dot structures, 8 is going to be the most that we put around them. The reason for this is because of S and P orbitals, which we're not going to get to in a great deal in this class. But each orbital is broken down into an S and a P, and we want only what's in the outermost. And in the outermost of everything, it's always 8. So we can only do 8. And again, we start on the right, and we go around clockwise, and then we pair.
She's a diva. I feel the same and I wanna meet her. They say she low down. It's just a rumor and I don't believe her. They say she needs to slow down. The baddest thing around town.